the rest of the chapter, excuse me, the rest of the section is on converting equations. We have equations converting from rectangular to polar, and then we have from polar to rectangular. So those same conversions that we used for the ordered pairs are the same conversions that we're going to use here, okay? So there's lots of different ways that we can do these problems. One is y is equal to r sine of theta, x is equal to r cosine of theta. I can divide both sides by r. R is always going to be a value, even though it's a variable, it has to have some kind of a length. So sine of theta equals 3 cosine of theta. And we want this to be as simplistic as we can, so I'm going to divide both sides by cosine of theta. And sine divided by cosine is tangent. So tangent of theta equals 3. If you could nicely go further, okay? So let's say this was tangent of theta equals pi. Then you would say theta equals 0, and you would continue on. But this is not a nice number, so we're gonna, that's as nice as we could leave it as an exact answer, so we're gonna leave it tangent of theta equals 3, okay? Simpler than this, if you learn to recognize that I'm gonna divide both sides by x, so y over x equals 3, y over x is equal to tangent of theta equals 3, and we're done, okay? All right, this one. Lots of different ways that you can do this, okay? I am going to FOIL this first, so I have x squared plus y squared minus 6y plus 9 equals 9. A couple things happened because I did that. Number one, I can subtract 9 from both sides right away. Another quirky one, x squared plus y squared equals r squared. Okay, I didn't have that specifically written down. I said it, and I had r equals the square root of x squared plus y squared. But x squared plus y squared equals r squared. So I can replace x squared plus y squared with r squared. And then I have negative 6 times, and in place of y, I have r sine of theta. So then I get r squared minus 6r sine theta equals 0, okay? Again, r is some number, so I can divide everything by r. So I have r minus 6 sine of theta equals 0, or r equals 6 sine of theta. You want to have, if you can, either a single trig function, r equals, or theta equals. One more, converting from rectangular to polar. X is r cosine theta. Y is r sine of theta, but this is squared. So if I square this, that's what I've got. Same as the last two problems, I can divide by an r. Now, I have a cosine and a sine squared. Going back to those identities, sine squared is equal to 1 minus cosine squared. So I can replace that. So I have cosine theta equals 1 minus cosine squared theta. I am going to, and then times r. Can't forget that r. I'm going to divide and actually that's not going to help us. Now that I realize that my r is there, just kidding, I'm going to leave this as a sine squared. Sine squared. We want to get r by itself. Sometimes you can replace things. This is not one of the times that you want to do that. Now that I look at it again. If I divide by sine squared, Again, we want to clean this up. So I'm going to have 1 over the sine of theta times cosine of theta over the sine of theta equals r. 1 over the sine of theta is the cosecant, and cosine over sine is the cotangent. And that's as simplistic and as nice as you can get that one.